Okay, so this is the class example program, unit B3, page 3. Let's take a look at the program statement first, okay? This is a YouTube manometer. Manometer is attached between two pipes. It looks like this is the oil pipe, this is the water pipe. So YouTube manometer containing mercury is attached between those two pipes A and B. Okay. And as a result, this manometer contains oil, mercury, and water. Okay. And then those are the height of each liquid. This is the oil, 4 inch and 3 inch. Mercury is 12 inch, 1 foot. Here is the water starting from here all the way to pipe B. Okay. So out of this configuration, let's determine what is the pressure difference between pipes A and B. So this is differential YouTube manometer configuration. So let's take a look at how to do it. Okay. So this is the same exact figure on the whiteboard. So what are we going to do? We are going to obviously apply manometer equations. Manometer equations, P is equal to gamma H. Now in this case, we are trying to look into the pressure difference between 2 points. So in that case, you can express this equation using delta P. Pressure difference between any two locations is equal to gamma times delta H also. Change in the height is going to determine the change in pressure. If you assume within the same liquid, specific weight is constant. Okay? We derived this equation, so we are going to use it. So this is the center of the pipe A. This is the center of the pipe B. You can start from right here, applying this equation all the way to pipe B. Or alternatively, you can do the reverse order. You can start from here, again applying this equation all the way back to A. Either way is fine. It is going to produce the same result. So I'm going to start from here, then go all the way to B. So let's begin from here. Right here in the center of the pipe A, pressure is PA, whatever it is. Okay? So this is the pressure of the center of the pipe right here. Now, we are going to take a look at from here to, right here. Right here. So right here, pressure is the same as here because there's no depth difference. Okay, same depth within the same oil, so the pressure here is exactly the same pressure PA. Oh, that's good. So what about if you go down, maybe up to this point? What is the pressure here compared against here? Pressure here is whatever the pressure here or here, which is PA, plus gamma times delta H. Delta H in this case is 7H. Okay? PA plus gamma of oil times 7 divided by 12, make it foot. 7 over 12 foot. So this is the pressure in terms of gauge right here. So this is the pressure right here. Okay? So now, starting from here, let's just go a little bit more down and hit here, right here. Pressure here is higher pressure than here because you go deeper. How much higher? Well, gamma times H. So you just add gamma of mercury multiplied by 12 inch, which is 1 foot. What is this pressure? This is the pressure right here. That's the gauge value of the pressure right here. Okay. Then you are going to go down a little bit more, then stay the same pressure because it's the same depth, same liquid. Then you're going to go start to back up. Then as you reach right here, this place and that place is exactly the same pressure. Okay, because it's in the same depth, same height, within the same mercury. Pressure right here is equal to pressure right here, which is this value. Okay, so let's start from here. Let's go back up a little bit more. Let's go all the way to here. What is the pressure here? Pressure here relative to that is whatever the pressure value given here minus gamma of water times this much height. That's a 15 inch. 15 over 12 feet. This is the pressure right here in terms of gauge. No, sorry, right here. This is the pressure right here in terms of gauge. Alright? Which is equal to, pressure PV. So this is pressure PV. Okay? So basically what I did was, starting from pressure PA, move into this location, same PA, move into this location, pressure becomes this much. Move into this location, pressure becomes that much. Moving from here to here, the pressure is the same. From here to there, pressure becomes that much. That is equal to pressure PV. This is called manometer equation. Manometer can come with lots of different configurations and lots of different liquids. Combination of multiple liquids could be. So each manometer you see, you have to derive this unique manometer equation. Then you can use this equation to solve the problem. In this case, pressure difference between PA and PB. Okay? So let's finish up. So PA minus PB, that's what we want. This is a delta P, pressure difference between pipe A and pipe B. This is going to be equal to gamma water multiplied by 15 over 12 foot. I just keep using feet. And minus gamma mercury times 1 foot. Minus gamma oil times 7 over 12 feet. So you can plug in the value now. If you look up the table, property table, you can determine specific rate of water, mercury, oil, standard value. So let's use that. Water is 62.4 pounds per cubic foot. Multiplied by 15 over 12 foot. The reason why I want to use foot is because it's a standard unit. Minus mercury is 847 pounds per cubic foot times 1 foot. Minus oil 57 pounds per cubic foot multiplied by 7 over 12 foot. If you calculate everything here, you're actually going to have a negative value. Negative 802.25 pounds per square feet. This is essentially PSF. And this is gauge. No, it's not gauge. It's just the pressure difference. PSF. Okay. Pounds per square foot. Pressure difference. Now, in this particular case, you get the negative sign in front. That really means that pressure B, PB, is larger than pressure A, PA. So this is higher pressure, this is lower pressure. That's why you get negative sign. Okay. Now, suppose if you start from B, then go all the way back to A, you are going to squeeze out exact same equation. You can get exact same value. Okay. Now, one thing I really want to emphasize, the common mistake of this type of problem, okay? Sometimes people take, okay, we'll start from pressure A, PA. Well, right here is the same pressure, PA. Let's go down this much. This is a PA plus gamma of oil times 7 inch. Sure, okay? Oh, which is the same pressure right here. And then, whatever the pressure here, this is PA plus gamma oil times 7 inch minus gamma water times 3 inch is equal to PV. That's a very common mistake. The problem here is pressure right here and pressure right here. These are not the same pressure. Pressure here belongs to the oil, although it's the same depth. This one is oil, this one is water. It's not going to be the same pressure, so you cannot do that. What I did was the pressure right here is equal to pressure here. Why is that? Because this one belongs to the mercury. This point also belongs to the mercury. So you can say pressure here are the same because it's in the same depth and same liquid. Okay, so let's be careful about that. Okay? That's it.